In the previous lab section, we defined verbs PLE for finding the primes less than a number and PEXP for creating the exponents of those primes. Using these verbs and putting this all together, we get our final Catalan generating program. Let's break this down a line at a time. The first line of the program calculates the list of primes that are less than 2n. We will use this list for the values of n and n plus 1 from the denominator because their factors are just a subset of the prime factors of 2n. The double verb precedes the value of y, which is the variable representing the right argument. The second line creates a list of the exponents for the prime factors in 2n using PEXP rank 0. The reason rank 0 is used for PEXP is that we want the exponents for each of the values of p calculated individually to get the total number of exponents for all the prime factors. The third line creates a list of exponents for the prime factors for n in the denominator. There's no need to recalculate the list of prime factors we obtained in the first line because we want the list to be the same length as the one for 2n, so that we can subtract the lists without having to worry about mismatched lengths. Of course, this list of exponents will have a number of 0 entries because there will be prime factors of 2n that are too large to be a prime factor of n. The fourth line does the same for n plus 1 in the denominator. The increment verb preceding y is what increments its value. The fifth line first subtracts the sum of the third and the fourth lines from the second one, and then converts the resulting list into extended type using the extended verb, so that precision is not lost for large numbers. Then the list of these exponents is matched to the list of prime factors and using the power verb restored to their full values. The result is then multiplied together to return the Catalan number. You may have noticed that we're beginning to deal with numbers that are so large that their display could be spread over several pages. This is not useful, and we can track our results more effectively by not returning the Catalan number itself, but instead return the number of digits of the number we calculate. We will use kitty n for this. And finally, we answer the question of whether we can calculate the 1,000,000th Catalan number on our personal computer. It turns out that using the techniques we've learned in the previous lessons that we can. It has 602,051 digits, and now you know why we won't be showing you the full number. The last 50 digits look like this. And it took us almost 68 seconds and a bit more than 100 megabytes to do the calculations. In the end, you can see that solving this type of a problem is not just a matter of throwing computing power at it. It's more about leveraging some math techniques and J programming to allow the computer to work smarter.